Good morning and once again welcome to my YouTube channel. We continue to learn mathematics in this channel. This is a channel of mathematicians, and of course we meet here to learn or to acquire more information and knowledge about mathematics. And today I want to introduce a new topic, that is numbers 7. Numbers 7 and numbers 7 is a topic that is going to be short and small, but very important. Of course, we have done number 6, and today we introduce ourselves to number 7. Don't forget to subscribe to my YouTube channel, Pearson and Excel International Maths. Follow and share widely so that we can work together. I want to discuss something to do with recurring decimals today. What you need to understand is that recurring decimals, especially when we write 0.3 and there's a dot on top of the 3, this basically means the 3 itself is the one which recur. So 0.333 and moving forward. If you write 0.23 and then there are 2 dots on top of the number, each one of them, this means the 2 numbers are the ones which recur, 0.2323 and moving forward. If you have a 0.056 and then the dot is upon the first after the decimal and the last, it means the whole range of these numbers recur. That means 0.056, 056, 056 and moving forward. If you have something to do with 1.234 and then you have these 2 dots upon 3 and upon 4, it means these are the only numbers that recur. 2 doesn't recur. So we have 1.2343434 and of course moving forward. And of course fractions that have an exact decimal equivalent are called terminating decimals. Fractions that have a decimal equivalent that repeats itself are called recurring decimals. So today we are not really looking at the terminating decimals because we just know terminating decimals. It's just like 5/2, which is 2.5, and it ends there. So this is a terminating decimal. But if you have 1/3, which is 0.3333, then you can easily say 0.3 recurring. This is now an example of recurring decimal. So I want us to just go to example 1 so that we learn how to change fractions into, or decimals into fractions. Example 1. And example 1 is telling us to change 0.5 recurring to a fraction. And these are the steps. Please follow me as I explain the steps. Let the original number be x, and step number 1, or that one, let the original number be x. And this is x is equals to 0.5555 and moving forward, because that was the original number. And step number 2, multiply out by multiples of 10 till you have 2 numbers that are identical after the decimal. They have to be identical after the decimal. I will explain this. Of course, if you do this according to this explanation in this one, you're going to have 10x is going to be Z5, because we multiply by 10, 5.555, and moving forward. And what you need to check after every multiplication, do we have this side identical to this side? If yes, you stop there and compute the two. If you don't have after the right hand side after the decimal point identical, then you multiply once, like you could say times 100x, which is going to be 55 point whatever. Then you can compare any, whether we have any two numbers within all those which you have multiplied out that are identical after the decimal point. Uh, step number three. Operate the two numbers that are identical, or rather subtract, let's say, subtract out the two numbers identified. This is A, this is B, and this is C, identified in B above. Subtract out the two numbers identified and the point number D. After you have subtracted, then make X the subject of the formula. I will show you how. Make X the subject of the formula. And I want to use example 1, to do all this. So we know X has been said to be 0.5555. 10x, if you multiply by 10, 10x is going to be 5.5555. And yes, this is identical. These two numbers are identical. That is part B. Part C now, subtract out the two numbers. That means 10x minus x, which is the same as 5.555 minus 0.555. And 10x minus x, we get 9x, which is also equals to 5.555 minus 0.55, which is equals to 5. And this means you have subtracted out the bigger minus the smaller. That means you have 9x, which is equals to 5. The last point is make x the subject of the formula. So if 9x is equals to 5, divide by 9, our x is 5/9. And hence, this is now equivalent to 0.555, or rather equivalent to 0.5, recurring in fraction form. Remember, this is the most accurate because it's simply a fraction. And that is just like what we wanted to establish. And probably I may want to terminate there and talk more about example 2 and example 3 in a different video moving forward. All right.